I'm refreshing.
Yep. Yeah, it's not up yet. And it looks like it's up now. Yep. Let me just check, make sure we're doing what we gotta do.
I'm waiting for it to refresh.
Yeah, it should be live. I made it on my end with my regular computer, but I gotta play it through my phone to check and make sure that I've got the audio coming in all right.
All right, here I am.
It's funny, if I play it through my computer, it starts to loop because then it hears my computer and then it plays it in the video again, but then it plays, you know what I'm saying? So it's kind of funny.
All right, it's just waiting for it to load up on my end.
Yep. Yeah, I don't know why it takes like a minute to like get it going. I love how all of our videos start with like, please, you know what I'm saying?
There I am.
Trying to figure out stuff. Oh, it's good? You got it going? All the videos start with like
oh.
Please, you know what I'm saying?
There I am. I see.
Oh, see, now you gotta kill the audio.
Which one do I have to mute it in? In Google?
No, you mute it on YouTube. See, now you gotta kill the audio.
Yeah.
Mute it on YouTube. See, now you gotta kill the audio.
Yeah.
Oh no. There we go.
Okay. That should be good. Yes?
Yep, there's no more of that going on. The looping. I just, it's not popping up. Oh, now it is.
Okay. Now it's good. I muted it.
Alright. Yep.
All right.
Testing the audio. Audio sounds good.
Yeah.
I guess we'll just wait a minute or two, get some people in here, but we already have 4, unless that's just you and me. Could be.
5. I see 5.
That's cool. Howdy, folks.
Hi, guys. Happy Monday.
Beautiful day outside.
Lovely.
Absolutely
I
beautiful.
feel like it was raining last week, too.
Wasn't it? It might have been. Oh, yeah, we were talking about how nice it was over the weekend, right? And so far, the weekends have definitely been nice and bright and sunny. But, yeah. Oh, boy.
That's my kids in the background. I have no idea what they're doing, but they're making noise.
Anyway, while we're waiting for people to join the stream, I guess we'll throw out that there is still the assignment that is due for today. It's a Castle Learning. It's about the first surface processes unit, so there's, I think it's like 30 questions or so. If you haven't had a chance to log on and get that completed, again, it's due tonight at 11:59. So make sure you go into Castle Learning, and then also go into Google Classroom and just, I think you check off like that you completed it so that we know through both systems that you're good to go. So just make sure you're on top of assignments, that there's always something due on Monday night, and there's always something due on Wednesday night. And we give those things out on Monday and on Wednesday. So that's kind of the loop we're trying to get familiar with.
Yes, remember, we're in 4th quarter now, so all the work that we are assigning is getting graded. So just keep that in mind. We'll be a little bit flexible as far as when you hand it in, but you know, you got to try to do it in a timely manner.
Absolutely.
Oh, kind of looks like it's snowing a little bit here.
Yeah?
Yeah.
I mean, it was literally raining sideways before, and I freaked out a little bit. It's pretty funny. But yeah, let's cross our fingers, folks. Hope that the power, the internet stays active with all this wind. Gusts up to, what was it, 50 to 70 miles per hour, depending on where you were. I know that's a little bit more South Shore, but oof.
Yeah.
It's no joke. So who do we have watching right now?
Let us know who's here.
Yeah, say hi. You got to remember, we're just like looking at cameras. Like, it's kind of weird to project to a camera and not know exactly who's on the other end, you know?
It definitely is weird. We're just watching ourselves,
Pretty
which
much.
we don't normally get to do. So
No, it'd
it's
be
kinda
weird
funny.
if there were just a bunch of like you and I just like sitting in the desks and we were talking at ourselves.
Oh, Brady's there. Hi,
Hey,
Brady.
Brady. Tried and true, Mr. Parks. Always here for the live lessons. Shout out to Mr. Parks. Your attendance will be forever immortalized on YouTube as being a good egg.
Absolutely.
All right, well, I guess this is what we're gonna get. We waited 5 minutes, so might as well get started. I suppose most of you must have some overlapping classes, and that's fine as long as you get a chance to watch this video whenever you can. Oh, hey, Victor, how's it going? Anyway, for those of you who are watching it late, totally cool. Just stay on top of things. And as always, our office hours are, for myself, 12:45 to 1:30, and then for Astro, 1:30 to 2:15. So if you do have questions, you're watching this later, you want to pop in and ask a question, go for it. That'll be posted on the Google Classroom through Meetlink. So you just click the link, and you'll be in a lobby with us where we will be just like hanging out, waiting for you guys to join. So feel free to come in, with questions, or if you just want to hang and chat about something, totally cool.
Absolutely. Anyway. It'll be 2 separate links. Mr. Duprez will put his up first, and then I'll put mine up after.
So that brings us to what we are doing today, which is we are talking about the ocean. Now we're going to start off with a question that's near and dear to our hearts, which is, what keeps Long Island from sinking into the ocean? It's an island, but how come it doesn't just like sink, right? Wow. What's keeping it up there? Is it like a bubble of air? Is it just buoyant like a ship? Like, what's going on? What's underneath your feet? How deep does the sand and the soil go down? So that's what we're thinking about, getting an idea of like what's going on with the ocean, and specifically like Long Island. What's going on with that whole thing?
For those of you watching, anyone have any idea or want to take a guess?
Land is under it. Guess number 1. Thank you, Victor. Any other guesses? Or maybe just no. That was pretty fast, Victor. I'm feeling the confidence. No? All right. Well, we'll move on. We'll get to that question later again. So, we're talking briefly today just about oceanography. The exploration and scientific study of the ocean and its physical phenomena. So we're talking about the actual structure of the ocean, because you look out, it just looks like flat, blue, it's got waves, but what's going on underneath? There's actually quite a bit going on, and it gets a little complex at some points, but there's some pretty easy to spot features, and that's really what we're going to be going over. So, oceans do cover 70% of Earth's surface. Life originated from the oceans, which is pretty neat, right? Everything started there and crept its way up to land over time. Seafloor is covered with sediment, is another thing we need to talk about. And there's 2 types of sediment that you get, which are sediments that originate from the land and wash in. That's terragenous. So that, you think of it like terrestrial. So that's coming from the land itself, and then pelagic. So that is stuff that originates already within the ocean. That's mostly like skeletons, and that makes up limestone and rock that deposits in like the middle of the ocean. So 2 different terms. These aren't terms necessarily that you need to like memorize or anything, but keep in mind that the ocean has a lot of inputs and things swirling around, and it gets, again, pretty complicated with all the things that are building up, even if you're not thinking about it, right? You wouldn't ever think, maybe, off the cuff that like skeletons would be making rock in the middle of the ocean, but it is true. It does do that. So, moving on. We have some features that we are going to identify. This is looking from like a mountain range, these are streams, and then this wavy white line here is showing where like the beach would be. So we hang out, if you go to the beach, like, a little bit in, a couple feet out, but there's this whole area here that's like that land that extends, it goes sharply down, and then you get to this really big flat area. So we haven't learned these terms yet, but that's the idea of what we're looking at. We're looking at some of the features like, okay, well, where does the ocean start? How does it look? What's going on with that? And so that brings us to a few more terms. And all the terms are going to be up front today. This is pretty much it.
Can you adjust the size of the screen, Mr. Duprez? I think it's some of it is cut off.
Oh, yeah, I could do that. I can go into this and, well, I can't do this screen, but I can change your size and my size. Is that better?
Yep. I think some of the stuff from the top of the notes is cut off, it looks like.
If you try scrolling up on YouTube, I think you'll find the rest. 'Cause I see it. Can you guys see everything okay?
All right. I had to adjust something on my end.
Oh, okay.
I got it now. Okay.
Yep. No, it looks like it's all good.
Okay. Got it.
Cool. So, a couple different terms that we're going to look at, and again, these aren't anything you have to like memorize, but just giving a couple names to these specific features that we just saw on the coast. So, we've got a shelf, which is, if you think of like what a shelf looks like in your house, right? Shelf is like something you can like put things on. It's usually like horizontal, it's flat. That is that first part that juts out. So, if we look back, going to this, bam. This would be the shelf, the first part that juts out from where like that beach area is. So this right here would be that continental shelf. So this is a pretty shallow part, relatively speaking, in the ocean. You get a lot of life that lives in this area, a lot of fish like that area, because a lot of plants live on the shelf before the water gets too deep for light to come all the way down. So it's a very active part of the ocean itself. But continental shelf, we'll see, can extend pretty far out. This one shows it cutting pretty quickly from the land. But we'll show you a picture of Long Island later to give you a better idea of like, well, where does that shelf end for us? Like if you swim out, all of a sudden, if you look down, is there like this huge drop off? You'll see it's quite a few miles before we get to the next part, which is the continental slope, that steep decline that goes from the shelf way, way down until you get into what we call like the plains. So you get this abyssal plains, this really, really flat, low part of the ocean, part of the sea floor. And with that, we can get some sediment that makes what we call a continental rise. And there can be some canyons in that slope leading down to the plains. So again, none of this you really need to memorize or anything like that. But
No.
just looking at the features, this is kind of what it looks like. So you got your shelf coming from like the beach area. It goes down, whoa. It goes down on this really, really sharp decline. And then you get left with that flatter, deep ocean floor that's like the abyssal plains.
Right, that's the deep, deep ocean.
So to get an idea of like life and where certain things live, because that's kind of the cool part of all these different ocean layers, right? Like what lives all the way deep down? You got like whales, you got like some sea stars, some weird eels. You've got those anglerfish with the cool little light on the front that you might have seen from like Finding Nemo. But up here, photic, as in like light, right? Like photo, like using light to capture something, right? This is where all that like teeming like reefs and all those kinds of things are. And also at the top you get like the sharks, the dolphins, turtles. So a lot of things live in the top, and you get the like weird, creepy, cool stuff that lives at the bottom. But yeah, so again, all that life is on the shelf. You got that steep decline, and then you've got that really, really low abyssal plains all the way down here. So here is a picture of New York and Long Island, and you can see that the continental shelf is pretty far. How far away do you think that is? Like, it's got to be over 100 miles, right? If that's Long Island.
Easily.
So how far is Long Island tip to tip? It's like 100 and something, right?
120 miles.
120. So if you like take that and you like put it sideways, yeah. So the continental shelf is somewhere around 100 to like 150 miles out from like the beach. So no, you're not gonna like fall off into the abyss if you swim out a little too far. There's other dangers, of course, but the shelf itself is pretty far. You get that break where it goes down to the slope, and then out here is that huge flat abyssal plain that extends all the way out. And there are some features that we're going to see in that abyssal plain, but I just think it's cool to think like, you know, here we are, and there's this whole shelf that builds out all the way until you get to that huge decline. But that's, yeah, more than 100 miles out from us.
Any questions with that stuff so far?
Nah. So here we could see, here is Hudson River, and it is flowing through this area. If you look at the shelf itself, except it's not flowing through now. It was going through it sometime in the past, and it left, as we saw with rivers, right? It had that down-cutting valley. So you get this V-shaped stream valley that is probably very, very old, from when the sea level's really low, from, you know, around the time of the Ice Age. And so this cut into it, and you can even see here that it continues that path all the way down to the abyssal plains. So this is like an ancient riverbed of where the Hudson used to be flowing through, past Long Island, which is pretty cool. So it was like, again, an extra like 100 or so miles long. So what keeps Long Island from sinking? Well, Victor said it before, land. So underneath, right, here we are on the surface of Long Island. And underneath it, you've got all this different sediment, all these different rock layers. So it's not going to sink because it's on something, right? It's on a platform of rock. It just, you know, there's nowhere for it to go. It's just sitting nice on top of it. It's funny, if you don't really think about it, not many people really look at like what's underneath Long Island. They might think that there's just water or something like that. So I felt like it was an important thing to point that out, that we do in fact sit on bedrock that's underneath, and so we are not going to be sinking anytime soon.
No, definitely not, because it took a very long time for the land to build up, so it's not going anywhere.
So this is a video that you could watch about submarine canyons. It shows you that continental shelf. You could see the marine canyons here. You get that continental rise at the end, all the sediment that builds up. You can watch that later. We're not going to show it here. I don't think we can actually show YouTube videos on stream without getting some kind of copyright strike. I don't know, so we're not going to do it. But take a look. We're going to post the notes after this. That leads us to our next question. If the purple arrow is showing Florida, what is that yellow arrow showing? You've got like, right, here's like North America, there's Florida, here's the continental shelf, which looks, I think, really cool. You get to the abyssal plain, which is really long, and then all of a sudden you get this weird, like, stitched up area that runs right down the middle of the ocean. What in the wide world of sports is that? Plates? It's a good guess.
Any other guesses? What does it look like if you think back to one of the last slides we just had up?
An old river. Kind of looks like it's meandering. That's funny. Yeah.
Land, Cordelia. Hi, Cordelia.
Howdy. Well, I think that's everyone that's here because you've got the stream open and so do I. So we've got 3 guesses. The winner is, this is not quite the plates, but it's actually where the plates meet. So what it is it's something that's called a mid-ocean ridge, an undersea mountain range where new seafloor is created. So you have this volcanism that's pushing up new rock, and it actually makes this like deep sea mountain range that pushes things away. So this is the thing that we had that one supercontinent, right, Pangaea. You had rifting where these mid-ocean ridges were forming in the land before they were in the ocean, and it was pushing the land away as it formed. We're going to get way more into this when we get into dynamic crust, where we talk about earthquakes and the plates and all that, but for here, at least, we're just talking about the actual mountain range that forms as this molten material comes up into the cooler ocean and forms these kind of cool, like, volcanic mountains that stretch all the way through the ocean. Then also, there's a cool thing called the trench. You guys probably have heard of this. Really, really deep chasms, the deepest places on Earth. It might look something like this on the bottom right there, just like this huge dark void. I mean, it's so deep that like you can't even really get down there at all. So places that we've never really explored, the pressure's way too deep. Imagine having like the whole ocean over your head.
No, people can't go down there. We have to send submersibles down there. We have done that.
Yeah.
Not us per se, but teams of scientists.
Yeah, last weekend. But yeah, they need some pretty high-tech stuff because remember, like with the atmosphere, for the deeper and deeper you go, the more stuff that's over your head, the more stuff that's pushing down, the more pressure. So if you go into a really deep part of the ocean, it's literally like the whole ocean is over your head, pushing down, giving you that pressure on you. So they need some really, really thick, high-tech metals to withstand that amount of pressure. It would severely crush a person if they were down there. So here's a picture of what that might look like, right? We've got that shelf, you've got that slope, goes down to the plains. You've got ridges, right? Mid-ocean ridges look something like this. And then you could have those trenches which go way deep. Trenches are also related to the plates as well. So here's another video. It just takes a look at the volcanism happening at the ridge itself. Pretty cool. You might want to look at that when we post the link for sure. All right, and then getting to the last part of what we're going to talk about today, which has to do with something that's kind of funny. How is it possible that Scotland can have palm trees growing when it's at such a high latitude? So this is a picture of a castle in Scotland, and it does in fact have some of these kind of tropical palm tree looking plants. They are palm trees. They get palm trees there. How could that be possible? If you think of where Scotland is, it's north of us. I mean, it's over in Europe, but it is at a higher latitude. It's like where Canada would be. So how in the world does it have palm trees growing there?
Right, we did talk about this before, Victor.
It's true.
So what did we say? How is that possible?
Yeah,
That
we
there are
talked about
palm trees
this.
growing there.
Talk about this with climate. A stream of warm. Yes. Where does that warmth come from, Cordelia? Yeah, excellent. Yeah, you guys remember. Good stuff.
Yep, good.
So, ocean currents generated by winds and density differences. You've got them moving all over the world, bringing cold water from the poles down to the equator and the warm water from the equator up to the poles, right, in a big loop. So this distributes solar energy. All the energy that would be captured at the equator where it's getting the most gets transported. So water absorbs and stores large amounts of heat energy. The stored, it should say, energy moves from low to high latitudes. So what does that look like? Well, it looks something like this. So if you look here, the red arrows are showing you the warmer currents, and the black arrows are showing you the colder currents. So you can see all of the ones that are on the equator are usually warm. They go up, and then they come back down, usually cold, after they've released their heat to the colder area. So if you look over here, this is Florida once again. It's easy to spot. You've got the Gulf Stream, which is the name of this one, that goes all the way over to, right, the UK, Scotland up here. And it's going to release all that heat that it took in when it was over by us, right, over by the equator. And then it'll come back as a cooler current and then get warmed up again when it's on the equator. So we've got this heat distribution cycle going on where hot stuff goes to cold and heats it up a little bit, cold stuff goes to hot and cools it down a little bit, and that just continues and continues and continues. So you've got this image in your reference table, and
Yeah,
it shows
I was about
you,
to say that.
yep, it shows you the warm and the cold currents depending on the arrows. Here it's not red and black, it's black and white. So the black arrows are the warm currents and the white ones are the cool currents. And you can see it flips. So it goes from hot on the equator, comes down, gets cold as it lets go of its heat over here, and then cold comes back up on the west coast of South America, and it heats up on the equator, and that goes over and over and over again. And it makes these big loops. You can see that too, that there's 5 big loops. We call them gyres, where these warm and cold currents are circulating. That's pretty much it. I think that's Hola. Awesome popcorn.
Awesome popcorn.
So that's really what we got for you today.
Oh, hi, Johnny.
Hey, Johnny. Better late than never, right? You can go back. The stream will be up and available to watch if you want to catch the beginning again. but we kind of just went through some stuff with oceans.
Yeah, it's okay.
Don't apologize. We know that not everyone can make it to the live at 11, so as long as you're here, that's fine.
So to recap, we went over ocean features, ocean currents. If you weren't watching this live, just go through, everything that we went through. The assignment that you have today will obviously be related to this stuff.
Yep. So make sure every Monday that we put out a new assignment that's due on Wednesday. So we'll post that out probably in about an hour or two, just to give you guys some time to work on the other assignment. And that's the other thing, is that on Monday you do have the other assignment that we gave out on Wednesday. So today you have a castle learning that is due at 11:59 tonight. It is all about the first unit of surface processes. So that's weathering, erosion, water cycle, stream deposition, stream velocity chart, all that stuff. So it's a nice little summary of all the things we've been doing. Are you grading the castle learning based on the actual grade that you get? Yeah, we could talk about that later, but we're not going to say anything live right now.
We're still in the process of figuring out how things are going to be graded and which category in our grade book they fit in. It's an ongoing discussion with administration at the high school. So that's the best answer we could give you right now. It's not specific to the question that you asked, but we will let you know. And if we forget to answer it, Brady, just ask us again.
Yep, when we have more information about how everything is working, we'll let you know. But I would say in the interim, when you don't know, do your best, as always.
Anybody have any questions before we head out for today? I would say just focus on the ocean features: continental shelf, continental slope, abyssal plain, ridges, trenches, and then this chart.
Cool. All right, folks. Well, don't forget that we do have our office hours for my time. I'll be there from 12:45 to 1:30. If you go to the Google Classroom and click the link, you'll just be thrown right into a meet with me. I'll just be hanging out, waiting for anybody to come in. And then for Astro, that's 1:30 to 2:15. Same deal. The link will be posted. You just click it, and you'll be in a meeting. So if you have any questions, you can ask them there. We will be there. So I think that's just about it. Do your assignments and enjoy a nice, rainy, stormy day.
Yeah, absolutely. Otherwise, we'll see you Wednesday or later.
Yep. All right, folks. Adios.